In 1944, as the German army retreated across France, they relied on a strategy as old as warfare itself: scorched earth. Field Marshal Walter Model and his staff officers were realists. They knew they could not defeat the Allies in a head-on clash of firepower. The Americans had too many tanks, too many planes, and too many shells. But the Germans believed they could defeat the Americans with geography. France is crisscrossed by rivers: the Seine, the Marne, the Moselle, the Meuse. It is dotted with ancient towns with narrow streets. The German engineering doctrine, led by the pioneer, combat engineer, battalions, was highly professional and destructive. As the panzers pulled back, the pioneers went to work. They blew up every bridge. Not just the big ones, but the small stone culverts over creeks. They dropped church steeples into the middle of roads to create massive roadblocks. They mined the shoulders of the roads so vehicles couldn't bypass the rubble. They felled trees across forest paths and booby-trapped the branches. The German commanders calculated the delay factor of these actions with mathematical precision. A blown bridge of this span, a German staff officer would note, will require 2 weeks to repair. We have time to regroup, dig in, and prepare a counterattack. They believed that an army as mechanized as the American one was shackled to the road network. If you destroy the road, you stop the army. They viewed the Americans as road-bound. They thought that without a paved surface, the Shermans and the heavy trucks would bog down. This strategy gave the retreating Germans a sense of security. They would look back at the plume of smoke from a destroyed viaduct and think, "We are safer now." They scoffed at the idea that the Americans could cross a major river without capturing a bridge intact. They believed that bridging was a slow, deliberate process involving pile drivers and heavy cranes, equipment that couldn't be brought to the front quickly. The German mindset was rooted in the scarcity of their own equipment. Because they lacked heavy earth-moving machinery, they assumed the enemy did too. They didn't realize that they were fighting a nation that had just spent the last decade building the Hoover Dam and the Empire State Building. They were fighting a nation of builders. And the American response to a blown bridge wasn't to stop and wait. It was to build a new one, better and faster than the original. If the tank was the king of the battlefield, the bulldozer was the ace in the hole. The United States Army Corps of Engineers brought a secret weapon to Europe that the Germans simply didn't have: the Caterpillar D7 bulldozer. In the German army, earth-moving was done by men with shovels. Maybe, if they were lucky, they had a few small tractors. In the U.S. Army, every engineer battalion had massive, armored bulldozers. When American troops encountered a German roadblock, a pile of rubble from a destroyed building that the Germans calculated would take days to clear, the response was immediate. A D7 dozer would rumble to the front. The operator, often exposed to sniper fire, until they started welding armor plate to the cabs, would drop the blade. The diesel engine would roar. The tracks would bite into the pavement. And the mountain of rubble would be pushed aside in 10 minutes. The German defenders, watching from a distance, were stunned. They saw obstacles that had taken them hours to construct being dismantled in seconds. The bulldozer didn't just clear roads, it built them. When the Germans blew a crater in a road, the dozer filled it. When the Germans mined a road, the dozer simply scraped the top 6 inches of earth off the road surface, mines and all, and pushed them into the ditch. It was a brute force solution to tactical problems. The Germans called the dozer the Amerikanische Schneepflug, American snowplow. They learned to fear it. They realized that you couldn't block an American column unless you destroyed the dozer. So, German snipers and anti-tank gunners began to prioritize the bulldozers over the tanks. Shoot the yellow beast, the orders went. But the Americans had plenty of dozers. They used them to bury German bunkers alive. They used them to dig hole-down positions for tanks in minutes. They used them to carve airstrips out of apple orchards in a single afternoon. The presence of heavy earth-moving equipment at the very front of the spearhead changed the tempo of the war. It meant that impossible terrain was just a temporary inconvenience. The German commanders, looking at their maps, would say, "They cannot come through that forest. There is no road." The American engineers would say, "Hold my beer." And an hour later, there was a road. The Battle of Normandy almost stalled in the bocage, the hedgerow country. The ancient earthen banks, topped with thick, tangled hedges, were impassable to tanks. When a Sherman tried to climb over a hedge, it exposed its thin belly armor to German anti-tank rockets, Panzerfausts. The Germans had turned every field into a fortress. They laughed at the Americans' inability to maneuver. They believed the hedgerows were the ultimate anti-tank wall. American engineers tried blowing gaps with dynamite, but it was slow and alerted the enemy. The solution came not from a general or a scientist, but from a sergeant. Sergeant Curtis Kullin of the 2nd Armored Division. He realized that the German beach obstacles, the Czech hedgehogs made of steel beams, were littering the beaches of Normandy. It was high-quality scrap steel. Kullin designed a device. He cut the steel beams into jagged, sharp tusks. He welded them to the front of a Sherman tank. It looked like a majestic, terrifying set of steel horns. He called it the Rhino device. When a Rhino-equipped tank hit a hedgerow, it didn't climb over. It cut through. The tusks dug into the root system of the hedge. The momentum of the 30-ton tank pushed the earth and vegetation forward. The tank plowed right through the bank, taking a chunk of the hedgerow with it, and emerged into the next field with its gun level and ready to fire. General Omar Bradley saw the demonstration and ordered every tank in the army to be fitted with the device. It was a frantic engineering effort. Combat engineers set up field workshops. They stripped the steel off the invasion beaches. They welded day and night. Within a week, hundreds of tanks were modified. When Operation Cobra launched, the Germans were caught completely off guard. They were waiting for the tanks to come down the roads or try to climb the banks. Instead, the Shermans burst through the hedges, flanking the German positions, burying the defenders in dirt and debris. The Rhino was a prime example of American combat engineering: adapt, improvise, and overcome. The German commanders had relied on the terrain to save them. The American engineers simply reshaped the terrain to fit their tanks. The most iconic symbol of the Engineers' War was a lattice of steel panels called the Bailey Bridge. Designed by a British civil servant, Donald Bailey, it was adopted enthusiastically by the U.S. Army. It was a prefabricated, modular bridge kit. It looked like a giant erector set or Meccano toy. The genius of the Bailey Bridge was that it required no heavy machinery to assemble. Every part could be carried by 6 men. It used simple steel pins to connect the panels. It could be assembled on one bank of a river and then launched, pushed across the gap on rollers. The Germans blew every bridge across the Seine, the Loire, and the Meuse. They calculated that the Allies would be stopped for weeks at each river line. But the US combat engineers traveled with truckloads of Bailey panels. When they reached a blown bridge, they swarmed out. They didn't act like construction workers, they acted like a pit crew. They leveled the banks with bulldozers. They assembled the panels. They laid the decking. A Bailey bridge capable of carrying 40-ton tanks could be spanned across a 100-foot gap in a matter of hours. Not days. Hours. The Germans would blow a bridge at dawn, retreat 10 miles, and dig in. By sunset, they would hear the roar of American tanks crossing the river behind them. It broke their morale. "We destroy the bridge, and it grows back," a German prisoner reportedly said. The speed of the Bailey Bridge destroyed the German strategy of delay. It allowed Patton and Bradley to maintain the momentum of the breakout. The engineers built bridges in the rain, in the dark, and under fire. They built them over rivers, over ravines, and over craters. By the end of the war, the Allies had built thousands of Bailey bridges. Many of them remained in place for years after the war, serving the civilian population, a testament to the durability of a temporary solution. The German generals had scoffed at the Lego set bridge. But that Lego set carried the weight of the liberation of Europe. Before the bulldozers could clear the rubble, and before the tanks could advance, someone had to clear the ground itself. The German army was the master of the minefield. They sowed millions of mines across Europe. They used the massive telemine to destroy tank tracks. They used the insidious S-mine, Bouncing Betty, to maim infantry. They planted them in patterns that were mathematically designed to channel American forces into kill zones. The job of finding them fell to the combat engineers. It was the most terrifying job in the war. The engineers didn't always use high-tech metal detectors, which were heavy, unreliable, and useless against the new German non-metallic mines. They used a bayonet. An engineer would crawl on his belly in the mud. He would gently poke the ground ahead of him at a 45-degree angle. If he felt resistance, he stopped. He carefully scraped away the dirt with his fingers. If it was a mine, he had to neutralize it. Sometimes this meant unscrewing the fuse. Sometimes it meant attaching a rope and pulling it out from a safe distance, in case it was booby-trapped with an anti-handling device. All of this was done under enemy observation. German snipers loved to target the engineers. They knew that if they killed the minesweepers, the American tanks behind them would be stuck. The pressure was immense. Behind the engineer lay a column of Shermans, engines idling, commanders screaming for the lane to be cleared. Once a path was clear, they marked it with white tape. Stay between the tape, and you live. Step 1 inch outside, and you die. The German commanders relied on these minefields to buy time. They calculated that a dense field would delay the Americans for 24 hours. But the American engineers developed a ruthless efficiency. They practiced breaching under fire. They used Bangalore torpedoes, long pipes filled with explosives, to blast paths through wire and mines simultaneously. They didn't just clear the mines, they obliterated the ground they sat on. The German defenders watched as their carefully laid traps were detonated in sequence, clearing a highway for the tanks in minutes rather than hours. The courage of the human minesweepers was the lubricant that kept the mechanized army moving. While the frontline engineers fought mines, the rear echelon engineers fought an enemy just as deadly, mud. The Red Ball Express, the massive truck convoy system supplying the armies, was destroying the French road network. French roads were not built for thousands of 2.5-ton trucks and 40-ton tank transporters driving 24 hours a day. The pavement crumbled. The foundation sank. When the autumn rains came, the roads turned into rivers of glue. If the roads failed, the army starved. The engineer regiments were assigned to road maintenance. It sounds boring. It was actually a desperate battle against physics. They couldn't close the road to fix it. The traffic had to keep moving. So, they fixed it under the wheels of the trucks. They organized gravel trains. Dump trucks would drive along the moving convoy, dumping gravel into the potholes. Engineers stood in the mud, shoveling the rock into place while trucks roared past inches from their heads. In the worst sections, they built corduroy roads. They cut down forests. They laid logs perpendicular to the road direction, creating a ribbed wooden surface. It was bumpy. It was slippery. But it didn't sink. The sound of trucks rumbling over a corduroy road was like a constant drum roll. The German aerial reconnaissance pilots saw the mud. They reported to Berlin that the American supply lines were impassable. They predicted that General Patton would have to stop. But Patton didn't stop. Because the engineers were working 20-hour shifts, sleeping in the ditches, eating K-rations with muddy hands. They operated rock crushers. They ran asphalt plants. They treated road building as a combat operation. The German generals, whose own logistics were paralyzed by mud and snow, couldn't comprehend the scale of the American engineering effort. They didn't realize that for every American soldier shooting a rifle, there was another soldier with a shovel ensuring he had bullets to shoot. The Red Ball Express kept rolling because the engineers refused to let the earth swallow it. Rivers are the natural enemies of tanks. Europe is full of them. The Moselle, the Saar, the Roer, the Rhine. The Germans blew every bridge. They sat on the far bank with artillery, confident that the water was an impenetrable barrier. They expected the Americans to use boats. Instead, the Americans brought the M2 Treadway Bridge. This was a miracle of prefabrication. It consisted of massive pneumatic rubber pontoons, inflatables, and steel trackways. It was carried on specialized trucks. When an armored division reached a river, the engineers sprang into action. They didn't need days. They needed hours. They inflated the pontoons. They pushed them into the river. They used power boats to hold them against the current. Then, cranes dropped the steel treadways onto the saddles of the pontoons. Pins were hammered in. The bridge grew out from the shore like a metal snake. The speed was blinding. A well-trained engineer battalion could span a 300-foot river in 3 hours. And this wasn't a footbridge. It could hold a 35-ton Sherman tank. The German artillery would spot the activity. They would rain shells down on the river. The engineers worked through the barrage. Shrapnel punctured the rubber pontoons. They patched them on the fly or swapped them out. If a section was destroyed, they unpinned it, let it float away, and dropped in a new one. The moment the last pin was hammered home, the tank started crossing. To the German defenders on the far bank, it was a nightmare. They had blown the stone bridge. They thought they were safe. Suddenly, a steel highway appeared on the water, and 30 tanks were roaring toward them. The Treadway Bridge negated the strategic value of the river. It turned a hard barrier into a soft inconvenience. The Germans simply couldn't react fast enough. By the time they organized a counterattack, the Americans had a bridgehead and were building a second bridge for the trucks. The ultimate trick of the combat engineers was the ghost road. German defenses were oriented around the road network. They placed their anti-tank guns at crossroads. They mined the intersections. They registered their artillery on the pavement. They assumed the Americans had to use the roads because the forests and fields were impassable to heavy vehicles. The Americans decided to make their own roads. Using the D7 armored bulldozers, the engineers would cut a swath straight through a forest or a hedgerow country. They called it cross-country mobility. The bulldozers would knock down trees, fill in ditches, and grade a dirt track in hours. They would lay down steel mesh, Sommerfeld tracking, if the ground was soft. Suddenly, an American armored column would vanish from the main map. The German commander at the crossroads would wait. And wait. Then, he would hear engines behind him. The Americans had bypassed his strong point. They had driven through the impassable woods. These ghost roads allowed the U.S. Army to maintain the element of surprise. They didn't have to fight for every village. They could just drive around them. It was a tactic that broke the German decision cycle. How did they get there was the constant question in German headquarters. The answer was usually a sweaty engineer on a bulldozer, smoking a cigar, carving a path through the wilderness. The ghost road saved thousands of American lives. They avoided the kill zones the Germans had so carefully prepared. They proved that in modern war, the map is not the territory. The territory is whatever the engineers decide it should be. March 7, 1945. The Rhine River. The Rhine was the last barrier to the heart of Germany. The Germans had blown every bridge across it. But at the town of Remagen, a miracle happened. The Ludendorff Bridge, a massive railway bridge, was still standing. The Germans tried to blow it. A massive explosion rocked the structure. The bridge lifted into the air and settled back down on its foundations. The demolition charges were too weak. American troops from the 9th Armored Division raced across. But the bridge was damaged. The decking was full of holes. It was wired with unexploded charges that could go off at any second. Enter the combat engineers. This was their finest and most terrifying hour. While infantry fought on the far bank to hold the bridgehead, the engineers swarmed onto the structure. Their job was twofold: cut the wires to the remaining German explosives, and repair the deck so tanks could cross. They worked under a hail of fire. German artillery zeroed in on the bridge. German snipers fired from the hills. The Luftwaffe threw everything it had left, including the new Arado 234 jets, at the bridge. The Germans even fired V-2 rockets at it. Through this inferno, the engineers worked calmly. They welded steel plates over the gaps in the railway tracks. They ripped up the rails and laid down timber planks for the tanks. They worked at night, illuminated by the flashes of explosions. Men were blown off the bridge into the freezing Rhine. Others took their places. Within 24 hours, they had turned a damaged railway bridge into a highway for Sherman tanks. The heavy armor poured across. The Rhine barrier was broken. But the engineers didn't stop there. They knew the bridge was weak and might collapse. It eventually did, 10 days later. So, right next to the damaged bridge, under the same heavy fire, they built pontoon bridges. They deployed the M2 treadways and the heavy floating steel bridges. The Germans watched in despair. They had failed to destroy one bridge, and now the Americans were building 2 more right next to it. The capture and repair of Remagen is often called the miracle of the Rhine, but it wasn't a miracle. It was a feat of extreme engineering courage. As the war entered Germany, the technological disparity became painfully obvious. The German army was defending its homeland. They had interior lines. They should have had the logistical advantage. But they lacked the machines to maintain it. German road repair was done by the Volkssturm, old men and boys, or slave laborers, using pickaxes and wheelbarrows. It was slow, back-breaking work. When a road was bombed by the Allies, it stayed destroyed for days. German tank columns would get stuck in traffic jams behind a single crater, unable to move forward or back, making them easy targets for air attack. The German engineers were skilled, but they were working with their hands. The American engineers were working with hydraulics. The U.S. Army brought thousands of pieces of heavy equipment to Europe: graders, excavators, pile drivers, and cranes. They had air compressors to run jackhammers. They had welding trucks. This mechanization meant that the Americans could repair a road faster than the Germans could destroy it. German officers captured in the Ruhr pocket often commented on the wasteful American use of machinery. "You use a bulldozer to fill a foxhole," one German noted. "We use a shovel." They viewed it as lazy. The Americans viewed it as efficient. Why waste a man's energy digging a hole when a machine can do it in 10 seconds? This energy conservation mattered. The American soldier was fresh. The German soldier was exhausted. The lack of German mechanization turned their retreat into a rout. They couldn't clear the debris of their own defeat fast enough to escape the advancing American dozers. Tanks need fuel. A lot of it. The Red Ball Express trucks were burning almost as much fuel as they delivered. It was inefficient. So, the engineers built a river of gas. Operation Pluto, pipelines under the ocean, brought fuel from England to France. But on the continent, the U.S. Army engineers built the Thmina system. They laid 6-inch and 4-inch steel pipes across France and Belgium, right behind the advancing armies. It was a linear factory. Teams of welders worked in assembly lines. One team aligned the pipes. The next team tack welded them. The final team finished the weld. Then, a pipe-laying machine, a modified tractor, would lower the continuous pipe into a ditch or lay it alongside the road. They moved at a pace of 30 to 50 miles a day. The Germans tried to cut the lines. But a pipe is easy to fix. You just cut out the bad section and weld in a new one. By the end of the war, the pipeline stretched all the way to the Rhine. It delivered millions of gallons of gasoline directly to the forward depots. This engineering feat negated the German strategy of attacking the fuel trucks. You can't strafe a pipeline that is buried underground or hidden in the tall grass. That pipeline engineers were the unsung heroes of the pursuit. They ensured that Patton's tanks never ran dry. They turned logistics into a utility. The fuel was just there, like water from a tap. The German generals, whose own tanks were being abandoned for lack of fuel, could not comprehend an enemy who could lay a pipeline across a continent in the middle of a war. When we think of World War II, we think of destruction. Bombs falling, cities burning, tanks firing. But the Allied victory was built on construction. The U.S. Army Corps of Engineers reshaped the geography of Europe to fit their needs. They built 150 airfields in France alone. They rebuilt 7,000 miles of railroad. They constructed over 5,000 bridges. They moved more earth than was moved for the Panama Canal. The German philosophy was Fortress Europe, static, immovable, defensive. The American philosophy was combat engineering, dynamic, mobile, offensive. The Germans waited for the Americans to come to them. The Americans built a road to get to the Germans. The bulldozer blade proved to be as decisive as the bayonet. It cleared the beaches. It buried the hedgerows. It filled the tank ditches. It opened the gates to Germany. In the final assessment, the German army was defeated not just by superior firepower, but by superior work capacity. They were outbuilt. The final shot of the documentary shows a rusted bulldozer blade sitting in a museum in Normandy. It isn't a gun. It isn't sexy. But it is the weapon that buried the Third Reich. The text overlay reads, "Amateurs talk strategy. Professionals talk logistics. But engineers make it happen."